You're holding a rock. Black, smooth, sharper than anything you've ever touched in your life. You didn't make it. You found it near a volcano, wedged into a ridge of gray stone, and when you struck it with another rock, it split into a curved edge so thin it could slice skin without you even feeling it happen. This is obsidian, volcanic glass, and roughly 700,000 years ago, at a site called Kariandusi in Kenya's Rift Valley, a human ancestor, Homo erectus, picked up exactly this material and used it as a working tool. That's the first known moment any human ever held glass. Not a window, not a drinking cup, not a lens, just a rock that happened to form when lava cooled too fast for crystals to properly arrange themselves. Glass existed on Earth for billions of years before anyone figured out how to actually manufacture it on purpose. And for hundreds of thousands of years after that first obsidian tool, humans kept using it constantly without ever understanding what it actually was, or that they could learn to create it themselves from scratch. Here's why that enormous gap matters more than it first sounds like it should. The moment someone finally figured out how to make glass from nothing changed the world more than almost any other invention in human history, arguably more than the wheel, and it probably started with an accident nobody in the room even noticed at the time it happened. Before getting to that specific accident, here's something that should genuinely surprise you, because it overturns something you've probably heard repeated confidently as fact for years. Glass is not a liquid. You've likely heard the old claim that cathedral windows are thicker at the bottom because the glass has been slowly, imperceptibly flowing downward for centuries. It's a myth, and a persistent one. Physicist Edgar Dutra Zanotto calculated in a 1998 paper published in the American Journal of Physics that it would take longer than the entire age of the universe, over 13.8 billion years, for ordinary glass to show any measurable flow whatsoever at room temperature. The uneven thickness you actually see in old windows comes entirely from how medieval glassmakers manufactured flat discs of glass, naturally thicker along one edge, which glaziers simply installed with the heavier side facing down purely by choice. What glass actually is turns out to be far stranger than that comforting myth ever suggested. An amorphous solid, atoms frozen permanently in a disordered, liquid-like arrangement that never managed to organize itself into a proper crystal structure, caught permanently halfway between two entirely different states of matter. Physicists still genuinely argue about how to classify it correctly even today. So how did anyone figure out how to actually make this strange in-between material on purpose? The earliest known man-made glass objects are small beads found in Mesopotamia and Egypt, dating to roughly 2500 to 2300 BCE, well over 4,000 years ago. The most widely accepted theory is that glass was discovered by accident during the production of faience, a quartz-based decorative material coated with a glassy glaze that was already popular across the ancient Near East. When silica-rich material mixed with the right flux inside a hot kiln, the surface sometimes vitrified into an actual thin layer of real glass. At some point, someone noticed that layer could be scraped off and produced deliberately on its own. A separate theory. From Assyriologist A. Leo Oppenheim's landmark 1970 study suggests the glassy slag left over from copper smelting may have provided the original spark instead. Either way, nobody set out to invent glass. Someone was trying to make something completely different, and got glass as an unplanned byproduct, which turns out to be how a surprisingly large number of history's most important inventions actually happened. And here's something most people never learn about this specific invention. Egypt and Mesopotamia appear to have developed glassmaking completely independently of each other. Archaeologist Andrew Shortland published a 2012 study using laser ablation mass spectrometry to analyze the chemical trace signatures of early glass from both regions, and found each region's glass carried distinct signatures matching its own local raw materials. Two civilizations, working with the same basic chemistry, stumbled onto the same invention on their own, without ever comparing notes. To actually understand what that accident required, it helps to know what ancient glassmakers were physically working with. The main ingredient is silicon dioxide, essentially ordinary sand, but pure silica melts at roughly 1,713 degrees Celsius, far too hot for any ancient furnace to reach. You need a flux, something that lowers the melting point dramatically, and the flux ancient glassmakers relied on was natron, a naturally occurring sodium carbonate mineral pulled from dried lake beds like Wadi Natrun in Egypt. Mix sand with natron, heat it to somewhere around 1000 to 1100 degrees Celsius instead, and the silica finally melts. There's a catch, though. Glass made from just sand and natron dissolves in rainwater. Fixing that requires a stabilizer, usually lime from crushed limestone or seashells, giving you a rough formula of about 70% silica, 15% soda, and 10% lime, a recipe that, give or take a few percentage points, is essentially still the formula used in most glass manufactured on Earth today. Not every ancient culture had convenient access to a mineral deposit like natron sitting conveniently in the desert, though. And that's exactly where the actual hands-on process gets genuinely interesting to picture in practice. In regions without natural natron beds nearby, ancient glassmakers and modern experimental archaeologists, trying carefully to recreate their methods today, turn to a specific plant instead, glasswort, sometimes called saltwort, a salt-tolerant plant that grows directly in coastal salt marshes, thriving in exactly the kind of muddy, waterlogged ground most other plants can't tolerate. Burn the dried plant down completely to ash, soak that ash thoroughly in water, strain out the solids, then boil the remaining water away entirely, and what's left behind afterward is a genuinely usable soda ash. Functioning as an alkali flux, almost identical in practical effect to mined natron, pulled straight from a dry lake bed. It's messy, slow, and nothing about the process looks remotely like chemistry from the outside watching it happen. Just an open fire, a bucket, and a plant pulled directly out of the mud at low tide by someone wading through a marsh. And that's precisely the important part. The entire process was fully achievable using nothing but materials any coastal or riverside community already had within easy walking distance of their own settlement. No trade network required, no rare imported mineral necessary, which genuinely helps explain why glassmaking could plausibly get reinvented independently in more than one place around the ancient world at once, by people who never once spoke to each other. For roughly the first 1,000 years after that accidental discovery, though, glass stayed a serious luxury item, not a common material at all. During the Late Bronze Age, roughly 1550 to 1200 BCE, glass was valued right alongside lapis, lazuli, turquoise, and gold. Diplomatic letters recovered from Tel El Amarna, exchanged between Egyptian pharaohs and other Near Eastern rulers around 1350 BCE, include actual complaints about the quality of glass sent as royal gifts, one ruler writing to the pharaoh essentially to say the glass he'd received was disappointing. Rulers were treating glass exactly the way modern heads of state treat gemstones, because at that point in history, it genuinely was that rare. The most important ancient glass workshop ever discovered sits at Amarna itself, the short-lived Egyptian capital built around 1350 BCE. Archaeologist Flinders Petrie first excavated the site in 1891 and found glass rods, canes, ingots in multiple colors, and the remains of actual furnaces. Later excavations led by Paul Nicholson of Cardiff University clarified that Amarna's glassmakers used a genuine two-stage process, first partially melting raw material into a rough mixture called frit, then crushing and remelting that frit at higher temperatures to produce clear, bubble-free glass. That's not casual craftwork. That's industrial chemistry running 3,400 years ago. And one single object connects this entire story to something even older than any human civilization. In 1922, Howard Carter opened the tomb of Tutankhamun and found a carved scarab beetle set into a ceremonial breastplate. For decades, it was identified as an ordinary gemstone. It wasn't until 1998 that mineralogist Vincenzo de Michel examined it with infrared spectroscopy and confirmed it was actually Libyan desert glass. A pale yellow-green natural glass scattered across the Great Sand Sea, formed roughly 29 million years ago by a meteorite impact or airburst hot enough to melt desert sand outright. Egyptian craftsmen found a fragment of glass created by a cosmic event millions of years before any human existed, thought it was beautiful, and carved it into a sacred ornament for a dead king's chest, with no idea whatsoever what it actually was. For the next 1500 years after glass was first deliberately produced, every hollow glass vessel on Earth was made the same painstaking way, called core forming. Shaping a core of clay and dung around a metal rod, dipping it in molten glass, then scraping the core out once it cooled. Each piece took hours. Glass stayed expensive precisely because nobody had found a faster way to shape it. Then, sometime around 50 BCE, somewhere on the coast of what's now Lebanon or Syria, someone had an idea that changed everything at once. They put a blob of molten glass on the end of a hollow iron pipe, and they blew. Glass blowing meant a trained craftsman could produce a vessel in minutes instead of hours, dozens in a single day instead of one. Glass went almost overnight, from an elite luxury material to something ordinary people could actually own. The earliest known blown glass vessels have been found in Jerusalem, dating to the mid-1st century BCE, and scholar Marianne Stern has argued the technique likely developed among workers already familiar with blowing through tubes for metalworking bellows, someone simply redirecting that same motion toward molten glass instead, and accidentally inventing mass production in the process. So look at the actual shape of this story: a volcanic rock, picked up and used without understanding for hundreds of thousands of years. An accident inside a kiln, noticed independently in at least two unconnected civilizations. A plant burned down to ash on a muddy shoreline, doing the same chemical job as a rare desert mineral. A cosmic impact, 30 million years old, carved into a dead pharaoh's chest by someone who never knew what they were actually holding. And a single breath, blown down an iron pipe, that turned an elite treasure into something an ordinary person could finally afford to own. Every piece of glass you've touched today, whatever it is, traces back through that exact chain, an accident someone happened to notice and decided to look at more closely instead of scraping away.